Hi, welcome back. Hononegah Honors, Algebra 2, Section 5.2, Day 2. We're going to continue doing operations with radicals. And this can get a little bit of challenging, especially for some people. This section is not easy. The first thing we're going to talk about is adding. And so it's kind of like adding like terms. So if you had 3x and 4x, it would be 7x because those are like terms and I can add their coefficients. Well, similarly, if I had the 3 square roots of 2 plus 4 square roots of 2, that would be 7 square roots of 2. And the only way to do radicals is similar to only the way you can do x's or variables is if you have the exact same radical. So in the very first question, I have 1 sixth root of 17 plus 9 sixth roots of 17, which would make 10 sixth roots of 17. And the next one is technically a radical, 7 to the 1/3 power and 7 to the 1/3 power. So if I had 5 7 to the 1/3 power plus 6 7 to the 1/3 power makes 11 7 to the 1/3 power. It'd be the same also as saying 11, cube root of 7. So you're looking at the next one and saying, well, I can't do that. I have a 4th root of 48 minus the 4th root of 3. Not so fast. Let's see if I can actually simplify the 4th root of 48. So 2 times 6, which is 2 times 3. I have 4 2's, so they go out. And I have the 4th root of 3 left over. So wait a minute. 2 4th roots of 3 minus 1 4th root of 3 would be 1 4th root of 3. So I can do it if I simplify and then add and subtract the like radicals. Now, for the first time ever, we're going to start talking about radicals with letters underneath the radical. So 27 is 3 times 9, 3 times 3. So the cube root of 27 is just 3. Now let's talk about d to the 12th. There's two ways of doing this, and I'm going to give you the harder way first. There's 12 d's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looking for groups of 3, there are 4 groups of 3, so it's d to the 4th. The other way of looking at it, and the easier way of looking at it, is the cube root of d to the 12th is the same as d to the 12/3. So anytime that you have a radical with a letter underneath with exponents, you technically are doing the exponent divided by the root, just like you did earlier in the chapter. So 12 divided by 3 would be 4. So in this one, you're talking about x to the 4/4, which is just x to the 1st, and y to the 16/4, which is just y to the 4th. Now, I don't have to do anything else to this because the denominator is no longer a radical. Remember, we talked all about that in the last section. If you have a fraction with a radical in the denominator, then you have to do more. But in this case, I do not because the radical is gone. So what happens then if things are not necessarily perfect? Remember, you're looking for 3 of a kind. Well, there's not enough number, so it's still just 2 inside. But a to the 13, if I drew out 13 a's, I could make 4 groups of a's, so they get to go out, but I'd have a single a left over. So let me draw that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So groups of 3. So if I had 13 A's and I said, hey, go into groups of 3, you would have 4 groups. So again, the groups go out, but I'd have a single A that was not part of a group, so it had to stay in. So if you're not part of a group, you have to go back in the radical. So the cube root of b to the 3rd. Well, there's just enough b's with nothing left over. And so the cube root of c to the 8th, there's 2 groups of c's with 2 c's left over. This question is on your quiz. And it's one of the most missed questions. And the one part that's missed a lot, and I take a half point off, is forgetting that it's still a cube root. So just letting you know right now that is one of the most common errors when simplifying is to forget that it's actually still a cube root that you're talking about. The rule is we're not allowed to have a radical in the bottom. And so I need to get to a situation where I have a perfect group of 3. 13 does not make a perfect group of 3. But if I multiplied by 2 more, and some of you are going to be looking at that going, what are you talking about? Cube root of 13 times the cube root of y squared makes the cube root of y to the 15th. The cube root of y to the 15th is perfect. It's y to the 5th. So now, just multiplying across the top, I end up with x squared, cube root of y squared. And that's the answer. So anytime you have a radical in the bottom, you cannot leave the radical in the bottom. And so if it's something that you need to multiply by, then you need to multiply so that it would be an even amount of numbers. So again, if I'm looking for a cube root, I need 3, 6, 9, 12, 15, 18, dot, dot, dot. And so 13 isn't enough, but if I multiplied by 2 more, then I would have a perfect situation. So next one, divide this up into separate problems. That's the best way for me to describe it. So 16 divided by 8 is 2. X to the first over x to the 2/3. We talked about this earlier. Anytime you have like bases, you can subtract their exponents. So 3/3 over 2/3 makes x to the 1/3. We also still have a y to the 1/3. Now let's talk about the z to the negative 4th on the bottom. You can't have a negative exponent. Negative exponent means reciprocal. So this needs to move to the top as z to the 4th, and that is your answer. There's nothing left in the denominator. Now for the top of the mountain then. Again, divide this up into separate questions. 9 divided by 81. Well, that's 1/9. So 9 over 81. X to the 2/3 over x to the 1/2. Anytime you are dividing with exponents, same like-based items, you need a common denominator so you can subtract. So this is 4/6 over x to the 3/6, which makes x to the 1/6 on top. Now, y to the negative 5/2 would make y to the 5/2 on the bottom and y to the 2nd on top. Remember, anytime you have like-based items and division, you can subtract. So now, y to the 4/2 over y to the 5/2 makes y to the 1/2 in the denominator, and we're going to have to talk about that in just a minute. Z to the 3/4, it's negative z to the 3/4 on top, so that makes z to the positive 3/4 on the bottom. All right. You are not allowed to have radicals in the bottom. Y to the 1/2 is technically a radical. It's a fractional exponent. And z to the 3/4 is also a radical. So I'm going to need to multiply this fraction by something that would make that an integer. So y to the 1/2, I would need to multiply by another y to the 1/2. Reason? Y to the 1/2 times y to the 1/2 is y to the 1st because I add the exponents. Next, I would need to multiply by z to the 1/4. Again, reason, z to the 3/4 times z to the 1/4 makes z to the 1st. And so this is your answer after basically simplifying each one. So simplifying the numbers, simplifying x, simplifying y, simplifying z. I ended up with fractional exponents in the denominator. And so I need to multiply to make the denominator have integer exponents. 6 cube root of x plus 2 cube root of x makes 8 cube root of x. We're going all the way kind of back to the beginning here. The next one, you're going to say, well, you can't currently do anything about it, but let's talk about this one over here. 2 times 24, 2 times 12, 2 times 6, which is 2 times 3. So there's enough 2's. So 16 4th root of 3p to the 6th minus 2p 4th root of 3p to the 2nd. Hold on, let me go back over here to the 3p to the 6th. There's too many p's. I can take out a full group of p's and have 2 p's left over. So this becomes 16p 4th root of 3p squared And so now I can add them together because they have the exact same radical. 16p minus 2p would be 14p. 4 through to 3p squared. Your homework assignment is out of the book. This is a very challenging one. You are going to have to spend some time on this. Make sure you check your answers. Make sure that you understand what you're doing. This would be a situation for some of you. You may actually be watching this for a second time because it is challenging. So during class, you probably went through the notes and things like that. I would recommend in class that you watch the video to maybe get a second explanation on this because, again, this is a challenging section. If you have any questions, make sure you ask, and good luck.